However, for today's lesson, we are going to just stick with homeostasis in human beings, but just remember that this process occurs in all living organisms. So what is homeostasis? Homeostasis is the maintaining of a constant internal environment. What do I mean by that? In the human body, there are a ton of processes that are going on. Your heart is always beating to pump oxygen and other nutrients throughout your body. Your bone marrow is constantly making white blood cells to help you fight an infection. Even blinking. And you probably weren't even aware of blinking until I just mentioned it right now. But these are all examples of things that your body is constantly doing. And there's a lot of information that it has to take in, and it has to sort out and maintain an ideal environment for humans. So, why do you guys think this ability to maintain a stable environment is so important for humans and other living organisms? Homeostasis is important for survival. Without homeostasis, a lot of things could go wrong, such as the resulting in different disorders. And we need to be able to maintain a stable environment so we can survive and we can live our lives to the fullest. So, how is homeostasis maintained? Homeostasis is maintained through what we call feedback loops. And there are two types of feedback loops. We have a positive feedback loop and a negative feedback loop. So, what are these two feedback loops? We're going to start with the positive feedback loop. This is where a reaction or a stimulus is detected in the environment, and this actually causes a reaction that increases the stimulus. So, for example, when you guys get a cut, a chemical is sent to the site of the wound saying, hey, we need more skin cells to help repair the wound. And that causes more skin cells to help repair the cut. A negative feedback loop, on the other hand, and we're going to label as P for positive and for negative. A negative feedback loop, on the other hand, is where we have a stimulus and it detects a change in the environment. But instead of increasing a reaction, what actually happens is the reaction actually is opposite. It is decreased. It can also be increased depending on what the stimulus was. But in a negative feedback loop, it is the opposite of what the stimulus is. So, what do I mean by this? Body temperature is a very good example of this. So, I'm going to show you guys an example. Let's say this is a human being. This is us, this wooden board. Homeostasis is all about maintaining balance. So, let's say it's a really hot day outside. It's 90 degrees, and we're going to let this candle represent the heat outside. As you can see, this balance is offset. We are now too hot. We need something to cool us down. And to do this, we thankfully have a built-in mechanism that cools us down. And this is what we call sweating. This water bottle is going to represent sweating. As you see now, this balance is equal. When we get too hot, we sweat to cool ourselves down. And this is the same thing for when we get too cold. When we get too cold, we actually start shivering, and that makes our muscles move, and that generates heat. So that way our body temperature rises again. When our body temperature gets too hot, we lower it. When our body temperature gets too cold, we increase it. this is going to be an example of a negative feedback loop. So now, you guys should know what homeostasis is, and you should be able to differentiate between a positive and a negative feedback loop. And I have also provided a worksheet that you guys are going to create that also demonstrates how homeostasis works. In conclusion, different organ systems work together to maintain homeostasis. Like you just saw in this example with body temperature, your nervous system sends a message to your